Hello. Trace tool is a graphical application to display, annotate, and analyze traces waveforms generated by the ChipScope. ChipScope is a Xilinx, now AMD IP, available on the FPGAs. When incorporated into the FPGA netlist, it, together with your chip model, can record digital and analog signals present inside your FPGA design. In that, it is similar to the oscilloscope. The difference being is that it allows you to access signals and wires of your design that are not routed to the external pins. This is extremely powerful. Similar to the oscilloscope, it exposes concept of trigger, conditions that activate the trigger, and a set of signals, i.e. traces, that are to be captured. In the lab, ChipScope is commonly activated through Vivado, Xilinx integrated development environment. When that happens and trigger is fired, it records the signals and transfers them to the host computer, at which point traces are saved in the CSV file. When armed and fired again, Vivado will overwrite the same CSV file. To display traces present in a CSV file, it is common to use Excel, and if one wishes to provide plots for presentation or do some analysis, often Visual Basic controls are added to the Excel pages. Loading and displaying these traces in Excel is slow and can be hard to do since lab users might not know Visual Basic well or simply not have time to code visual controls. This is where Trace tool comes in. It provides lab users with graphical user interface that addresses the most common tasks performed in a lab with ChipScope generated CSV files and does it without requiring user to learn or know any programming language. First, let's take a look at the content of such a CSV file. Here, I have prepared example CSV file containing several traces. First row is a header containing the traces names. Each column contains a trace, and in this particular case, we have 5 traces: sample and buffer, sample and window, trigger, trace related to signal foo, and XYZ. Second row contains radix information. The radix information indicates how the numerical values below are to be interpreted. This could be signed, unsigned, hex, octal, and bin. A trace tool correctly interprets these values, reads content of the second row, and correctly interprets the numerical values, properly interpreting them according to these radix. Now let's start Trace tool application and see how we can access content of this file. Assuming that you have already installed Trace tool, open PowerShell window and type TT and then press enter. TT is a name of this application on the command line. As you can see, all tabs, and there are 4 of them, are empty as we have not loaded any particular project. If you click on Help About, we can see that this particular review is about a version 0.0.2, which is really a minimal viable product at the moment. Now, to create a project, first we go to File, New Project. We give it a good name, My New Project. And we select a CSV file from which we will be tracking the traces information. This is the file. Now when we click OK, we can see all traces loaded from that CSV file. We can see at the bottom of the screen name of the project, name of the loaded project, and we can see that this project tracks the CSV file, this particular CSV file. When project is created, we are creating directory with name matching the project name, and we make a copy of the data stored in a CSV file, in the source CSV file. The data is stored in a compact binary format, But the important part is that since we are making a copy of this data, we are able to track the history of the traces. As you can see in the right lower corner, it says traces version 1. This means that we loaded only one version, and that's the first version. The version number starts from 1, 2, goes to 2, 3, 4, and so on. But the first version is 1 and not 0. Now, what else is there? We will come back to these various versions a bit later. First of all, we can see that if we double click on any particular trace, it plots the trace as it appears in a CSV file. And the name of the window is a trace label. Note that there is a distinction between trace label and trace name. Trace name is what appears in the CSV file. The trace label is something that is given to the user. When we open it for the very first time, when we create a project for the very first time, trace label and trace names are the same. By right mouse clicking on any particular trace, we can access context menu. One of the options is the rename trace label. We may want to do that to give it a more descriptive name or more compact. For example, in this case, we're going to replace that with XYZ. And this particular trace we're going to rename as simply foo. Now, when we look at, as you can see here, this is the title of the window. If we double click now, you can see that the title of this window is foo, as it should be. Now, not every trace will have a meaningful information. For example, sample in buffer, sample in window, maybe no signal appeared, and that might be irrelevant to you as a user. So one way to organize these traces is that you can mark them as inactive, and then they disappear from the tab active traces. And they actually simply move to the inactive traces tab. There's nothing special about this tab except the fact that it is different from the active traces tab, and it just allows user to organize the traces, relevant traces for his particular use case. So you can still plot from here, and they might still be irrelevant to you. So, and now let's go back to the active traces. Let's close these guys here for a second. So let's take a look at this trace. One important part here is that we do not necessarily have in a CSV file, we do not necessarily have information about a time step. We are assuming that time step for every point is 1, whatever physical units that might be. But you know that you yourself know what the actual sampling rate is. And so it's probably going to be in milliseconds or microseconds. At the moment, you can see here, this just goes from 0 to 8,000, whatever that 8,000 is. So what we really want to do, we want to be able to scale the time axis, the x-axis. So if we go to the projects tab, you can see here several things that we can change. One is a project name. We're not going to change it right now. You can see where the project directory is, where content of every the copies of every version of the trace is stored, and we can see the implied time step, which is 1. We can change that. Let's say we change it to 0.01, and then go back to the active traces and look at foo. And now you can see this from 0 to 8, while it used to be from 0 to 8,000. Now, the other important part is that the y-axis, and this is probably going to be voltage, is really an integer in a ChipScope CSV file, and it's some sort of a fraction of some scale. For example, this could be an integer from 0 to 255, 255 corresponding to 3.3 volts or what have you. Ideally, you want to be able to rescale this as well. However, that functionality is not available and will be available in the future, in the near future. Um, so if we click on the file settings, we can see options. These are the default values that are created when you start this application for the very first time. One is to automatically reopen last open project when application starts, and the other one is to watch source files for changes and notify user. So what it does when TT is running, when a trace tool is running and project is open, it continuously monitors content of this CSV file, and whenever it changes, it prompts the user, offering him to download new versions. So let's take a look at this. I have this tool here that mimics the Vivado, and what it does, it generates a newer versions of the CSV file that are slightly different. So let's click on Gen 2, and you will see here immediately it's been detected that trace source has changed and prompts the user to load latest version of the trace. We're gonna say yes, and when we do that, we will see that the version number will change from 1 to 2, and indeed that's the case. We're gonna click on 3, and that changes as well. Now it's version number 3, and we can again click to let's click 2. So and now it changes to 4. Now, how can we access? So a typical behavior is that you made some change. You run ChipScope capture. You didn't like the results. You're gonna change some settings in the FPGA, or you're gonna change in your chip, or you're gonna change the model itself. You're gonna change the netlist and run the capture again. So you probably want to see immediately before and after what the changes were. So we can always say in a context menu, there is an option plot latest and previous version of the trace. When we select that, we're going to see always 4 and 3 in this case, 4 being the latest one and 3 the one right before. And the same thing, of course, for this particular file. So that's the change between the latest and the one right before. What if you want to see other versions? We can do that by, again, going to the context menu and then selecting plot specific versions of the trace. Here, this text field is a comma-separated list of integers, where integers correspond to trace versions. Remember that trace version starts from 1, so if you want to plot everything, 1, 2, 3, and 4, we can do like that. And then indeed this shows us the plot with every possible label, with every possible trace. In this case, it looks like 3, but there are really 4. 2 of them overlap completely. But you can see here the legends for these traces exactly as we have requested. What if you want to see the latest version and the very first version? Or you have some reference version that against which you want to compare? Then one of the ways of doing it is that using the notation from Python for accessing arrays, negative value corresponds to the index in the array from the end of the array, from the right end of the array. So -1 will be the last value in the array, or in our case, this will be the latest version. So asking to plot 1 and -1 means to plot the first version, version 1, and plot the latest version, whatever that might be. And indeed, that's the case. We are plotting first and the latest, which is number 4. In a similar way, if you say this obviously works the same way for -2, which would be corresponding to the one before the latest version. So this is the same as asking, give me the latest version and the one right before that. So indeed, that's the case. The latest 4 and the one before is 3. So Now, a couple of machines left. In a project tab, you also have a description text area. This is the type of the additional annotation that you can add to your project, to the CSV file if you wish. Notice that there is no button to click OK or save. Anything that you type in here is saved automatically. For example, I can say this is a very important for projects for all of us. And let's say that is now saved. Now, remember, if we go back to the settings, we can see that it is selected to automatically reopen last open project when application starts. We can actually try that right now. And let's click OK. Let's go File, Quit. Have to close all these windows and then start it again. When it starts, it reopens this project. Now, if you want to open another project, you go to File, Open Project. You will see a new window. And here you will see list of projects. In our case, well, we have only one project indeed to open. So that is all for this version, and more is to come.